Valence electrons are the electrons that help the atom to bond to form compounds and molecules. And so these are very important. And we're not going to be talking about bonding in this unit, but we are going to talk about the valence electrons and how to count them and figure how many each element family has. So it does go by families, and you look at the Roman numeral number there. So starting right here, we have Roman numeral 1A. It has 1 valence electrons. 2A has 2 valence electrons. Go ahead and skip over the transition metals for right now. Go to the boron family, 3 valence electrons. Carbon family 4, nitrogen family 5, oxygen family 6, halogen family 7, and noble gas family 8. So 8 is the maximum number of valence electrons that you can have. When you look down at the transition metals and also the lanthanides and actinides, notice I just have there 2 valence electrons. Why is it that way? It's because the D and the F electrons are always inner electrons, so they're never outer electrons. Let's look and see vanadium. Vanadium, when we look at the electron configuration, we see that it has everything that argon has, plus 4s2 and then 3d3, because vanadium is right here. So we see that our s electrons have a 4 in front of them. That means they are the furthest out from the nucleus. Our d electrons only have a 3. That means they're inner electrons. So again, your transition metals will only have 2 valence electrons, and also your lanthanides and actinides. One way to represent the valence electrons is to draw something called an electron dot diagram. It's a way to represent the symbol of the element plus all of its valence electrons. So again, only the S and P electrons are outermost electrons or valence electrons. And there's a specific pattern that you're going to use. You'll write the symbol of the element, and then you'll write this little number pattern. So it's a little bit unique, so take a look at it. So you put 2 electrons in. So we're going to put dots for electrons, and this is the number pattern or the order pattern that we're going to put them. So we have 2 that go in together, and then we have the next electron has its own side. The next electron, the 4th one, has its own side, and the 5th electron also has its own side. And then after number 5, you're going to go back and just refill and complete the side. So let me give you a good example. So let's look at oxygen. So oxygen, we have 6 valence electrons. So I'm going to write the symbol for oxygen, and I'm going to put dots around it. So I could put 1, 2, 3, 4, 5, 6. Okay, so what is this telling us? This is telling us that I have, for oxygen, here is its electron configuration. Its s electrons are right here together. So these are the s electrons. And then its p electrons, there's 4 of them. And we haven't talked about orbitals yet, but you will put 1 electron in each orbital, and then that 4th electron will be in a shared orbital. So that's why it's shared here on the side. Okay, so if you follow this pattern, you can't go wrong. Also, you don't always have to start on the right-hand side and go in a clockwise pattern. You can start at the top and go counterclockwise, and you'll still get the same answer or the same pattern. So let's go ahead and try starting in a different location. So for oxygen, again, we have 6 valence electrons, so I can go 1, 2, 3, 4, 5, 6. And this is also correct. So what's important here for this element oxygen, I have 2 sides that are completely filled in, and then I have 2 sides that only have 1 dot. So that's what's important. So it doesn't matter what side you start on, but the pattern is important. The s electrons go in together, your p electrons go in separately. Let's go ahead and practice by doing some other elements. So we come to nitrogen. Write the symbol nitrogen, so N. And when you look on the periodic table, this is in 5A family. So this is the nitrogen family. They all have 5 valence electrons. So I need to put 5 valence electrons in here. I think I'm going to start at the top. Again, it doesn't matter what side you start on. So 1, 2, 3, 4, 5 is that. Let's go ahead and do chlorine. So chlorine is a halogen. It has 7 valence electrons. So maybe I'll start on this side. So 1, 2, 3, 4, 5, 6, 7. And let's do vanadium. So vanadium, remember, is a transition metal, and its electron configuration looks like this: 4s2, 3d3. Again, you never put d electrons in as the dots. It's only these s electrons. So we just have 2 dots here. So all your transition metals will only have 2 dots. They're actually kind of boring. So only 2 dots. So like zinc would only have 2 dots. If you do like an actinide, uranium, only 2 dots.